All right, guys, here's number 9 and 10 of our 6-7D packet that we were doing for homework tonight. Number 9 is a little bit different because it goes back into modeling, and it has some new expressions that you're not familiar with. So this rectangle right here is our representative of x. So if you want to write down here at the top, rectangle is equal to x, and the circles, an open circle is equal to a positive 1, and a dotted circle, or just a colored in circle, is equal to a negative 1. All right, so let's get to solving. Which of the following statements is true? We have 3 plus 2x plus a negative 4, so is equivalent to 1 plus 2x. Well, we can look here, and we see we have 2 x's, we have 4 negatives, and 3 positives. If I were to move these 3 positives over here, if you remember correctly, we've created something called the zero pair, because 1 and negative 1 together, saying 1 minus 1, gives us 0. So when we look at that, we get 2 x's minus 1, or plus a negative 1. Well, what it's told us is that it's equivalent to a positive 1 plus 2x. So A could not be our answer. All right, remembering what I just said about what everything represents, this says 2 multiplied by negative 3 plus x is equivalent to negative 6 plus 2x. All right, how many x's do we have? 1, 2. Well, that matches here. How many negatives do we have? 1, 2, 3, 4, 5, 6. We have 6 negatives. We have 2 x's. So this is a possibility. Let's go ahead and distribute to make sure that the drawing, the representation, isn't tricking us. So 2 multiplied by a negative 3, because we need to distribute to the first number, does give us a negative 6, and we need to add 2 distributed to our x. 2 multiplied by x gives us 2x. All right, looks like it checks out. So let's check the next one. C. Negative 3 plus x plus 3 plus x. Says it gives us a 6 plus 2x. Well, if we think negative 3 plus x plus 3 plus x. I have an x here. I have 1, 2 x's. But I have 3 negatives here and 3 positives here. And so when I draw those 3 positives over here, these cancel out to become 0. So all that's left are our 2 x's. That means that it could not possibly be 6 plus 2x, and that's not right either. All right, last one. Maybe we're going to go back to B. This shows 3 plus 2x plus a negative 4 minus x is equivalent to x. Well, we have a negative x over here, which takes away one of our positive x's. So we end up with 1x. And then we have a positive 3, and I'm going to move those over to our negatives over here. Oh, but look what we have. We have an x, but we also have a negative 1. So if we do x minus 1, that would be our equivalent expression, not just x. So D's not our answer either. All right, so B is our correct answer after all. Okay, so let's look at number 10. Last but not least, I am actually doing 6 of these with you, so you're welcome. But please make sure that you've shown all of the work that I have and that when you turn this in, it's totally complete. So which expression is not equivalent to 4 multiplied by 2x plus 6 plus 5 times 3? Well, let's go ahead and just rewrite this as 2x plus 6 plus 15. Do we see anything like that? Well, A has that, so that works. If we decided to distribute these and write it all out, we would end up with 4 multiplied by 2x plus 4 multiplied by 6 plus 15. And I see that here at C. Remember, we're looking for what's not equivalent. So that rules out C because they distributed, they wrote down everything they distributed. Let's actually distribute now. So we end up with 8x plus 24 plus 15. If we add that 24 and 15, we end up with 8x plus 39. Well, I see that here at D, so the answer should be B, but let's check it out. Why is it wrong? If we spread out our 4 times our 8x, we end up with 24x plus 15. So not only did they forget about our 6 somewhere in here, they completely tripled or quadrupled actually our, and this would actually be 32x, not 24x, my bad. Misread that. They quadrupled our x value. And so this is definitely not equivalent, and we have found our answer. All right, you guys, great job. Make sure your name is on the front of your packet and that you have this totally complete for tomorrow's class. I'm looking forward to seeing you again, and please come to tutoring. I am here. Just come in and check in with me, and we can talk about anything you're still confused about. Thanks, guys.